Welcome back. So today let's talk about estimating a population mean. Previously we were talking about estimating population proportions. Now we're going to go on to estimating population means, and in a future section we'll talk about estimating population standard deviation. An example: how many books per year does an American read? A recent poll asked 1,006 Americans how many books they had read in the past year. The answers of each person were averaged, and the result of this computation was X bar, the sample mean, was 13.4 books. We would like to use the result of this survey to offer an estimate, along with a confidence level for our estimate, of the average number of books read per year by the American population. So the population is all Americans. We'd like to estimate mu for the population. What we have is a sample of 1,006 Americans, and we have the sample mean X bar. Now, as before, this single number X bar obtained from the sample is called a point estimate. And remember that numbers describing samples are statistics, whereas numbers describing populations are called parameters. So we have a single number, a point estimate of the population parameter, but we'd like to give a range of values that we think mu might fall into, and in doing that we can give an estimate of our confidence of the of the procedure of our estimate for mu. Okay, so we've talked about confidence intervals already, and you remember from the confidence interval for a population proportion, we had the point estimate minus the margin of error and the point estimate plus the margin of error, forming the lower bound and upper bound of our confidence interval. And that's exactly how that's going to work here in constructing a confidence interval for the mean. It's just that this time our point estimate is a mean, not a proportion. And notice there's a different formula for the margin of error. So this margin of error formula requires that we know the sample size, that's n. The S is in there, that's the sample standard deviation. And something called T sub alpha over 2. So that's read T sub alpha over 2. That's how you read that. So notice this formula has no z in it. When we were doing the making confidence intervals for population proportions, the margin of error formula had a z in it. This one doesn't. Instead, it's got this t thing. In here, this alpha is a number that relates to the level of confidence. So remember, like for a 95% level of confidence, we said alpha would be 0.05. So you'd have 1 minus 0.05 gives you 0.95, and then times 100% to turn it into a percent.